Resolutions of vectors. Here we'll be looking at resolving vectors, but because we are looking at forces, so when I resolve, I'll be resolve mainly forces. But what I'm going to discuss here apply to all vectors, like your velocity, your displacement, and so far so on. In the previous chapter, we have learned vector addition. It involves adding up of two or more vectors to give the resultant vector. There are namely two methods to do vector addition. One is to draw a parallelogram. The second method is to draw the head to tail method. Okay, so now we are looking at vector resolution. Well, it is the opposite of vector addition. What we are doing here is you are given a vector and you have to break it up into its components. The components will be perpendicular to one another. Okay, so let's take a look at what does this mean. Suppose I have two vectors. One is vector A, the other is vector B. Okay, in vector addition, we learned that to find the resultant, we join the head to tail, and then to find the resultant vector, we just have to join from the common start point, which is here, to the end point, which is here. So the resultant will be from here. Oops. So the resultant will be from the start point to the end point, which is here. Okay, missed by a little, so it should end here. Let's suppose that I call this C. So C is the resultant of A and B. Okay, then vector A and B are perpendicular to one another. We can also use Pythagoras theorem to find out the magnitude for C, namely A squared plus B squared whole thing square root, and that will give me the magnitude for C. So this is vector addition. Okay, so when you say vector resolution, what we need to do here is to break your C, okay, this is the vector C, into its individual component, namely A and B, which are perpendicular to one another. So to do that, okay, I will first draw in the component B and A is above. So these two angles will be perpendicular. So I want to find what is this A in terms of C and what is this B in terms of C. And to do that, I need to know what is the angle for one side of the triangle. I already know that between A and B is 90, so I just need to know one more. So usually an angle is given. Let this angle here be theta. Next, we need to recall what you have watched in the video on basic trigo. So if you are given C, you want to break it out into two perpendicular components, namely your B and A. Okay, I will have to make use of trigo ratio. So let's take a look at the opposite component, which is your A. So this is opposite. C here is your hypotenuse. So I have opposite, I have hypotenuse. The trigo function that I need to use here will be sine. So, okay, remember in the video, the narrator actually introduced dua, ka, and so. Okay, but he didn't do it in this order. Okay, we do it in this order, dua, ka, so, because it's easier to remember. Okay, dua in Hokkien means big. Ka in Hokkien means leg. So means auntie. So dua, ka, so is actually big leg auntie. So from here, okay, we will have to use so. So that is sine. So according to trigo, your sine angle will be equals to opposite, which is A over C. So what is my A here? My A will be C sine theta. So this is the expression that we get. So usually you'll be given a magnitude for C, you'll be given a value for theta, then you press your calculator, you should get your answer for B. Okay, then we take a look at what about finding what about finding B? Okay, B is adjacent. You are given C, so you have adjacent. C is your hypotenuse. The vector that you want to resolve will always be the hypotenuse. Then here I will to use CAR. CAR is cosine. So in short we call it cos. So cosine theta will be equals to adjacent, which is your B, over hypo, which is your C. Therefore B will be equals to C cosine theta. So this is the expression that we get for both A and B after resolving C. Okay, now let's go back to the slides. Okay, here I'm going to give you one example. In example 3.1, there is a force F that is 60 Newton acting on the box. So you are asked to find the magnitude of the force pushing the box in the X and Y direction. Okay, so we need to resolve the force, which is 60 Newton, into two perpendicular components. One is X and one is Y. So you can see that if I were to shift my vector Y to here, Fy to here. Okay, let me enable the pen first. If I were to shift the vector Fy here, this is my Fy. Fy and Fx will be perpendicular, right? So Fy will be the vertical component, Fx will be the horizontal component. Then this 60 Newton is actually the resultant. So to find your Fx, so Fx is the adjacent, F is your hypotenuse. So you have adjacent, you have hypotenuse. The function that you need to use will be cosine. So same thing, we have cosine. The angle is given here is 35 degrees. Is equals to opposite. The opposite here is cosine is adjacent. The adjacent here is Fx, and the hypotenuse here is 60. Okay, so make Fx the subject. You should end up with the expression 60 cosine 35. Then press your calculator. Okay, you press 60 followed by the cosine function, and then you press 35. Then enter or equal. The answer is 49.1 Newton. To get this answer, you have to check that your calculator is in degree mode, because your angle can be in degree or radian. So here we are doing degree. Okay, radian is another unit for angle, so we are not using it here. Okay, then do the same thing for Fy, the other component, the vertical component Fy. Fy will be here, which is opposite. Okay, this is opposite over hypotenuse. So if you have opposite and hypotenuse, that will be your SO. So your sine 35 in this case will be equals to opposite, which is your Fy, over hypotenuse, which is your 60. So you should get the expression 60 sine 35. And if you press a calculator, you should end up with 34.4 Newton. So what we have done here is to resolve the 60 Newton force into two perpendicular components. One is in the horizontal direction and the other in the vertical direction. Okay, so also take note that because the two vectors, namely your Fx and Fy, they are perpendicular, so I can use Pythagoras theorem, check that the resultant, which is the 60 Newton, remains 60. Okay, this is to check whether you have resolved it correctly or not. So what you do is you take Fx, which is here 34.4, Fy here 49.1, use Pythagoras theorem to find out what is this hypotenuse. Okay, you do a check. If it's 60, same as the given value, that means you have resolved it correctly.